Hey guys, Mr. Backerberg here. In this video, we're going to take a look at polynomial functions. So we're looking at what the definition of a polynomial function is. So what we're going to do is let n be a non-negative integer, and then we're going to let a1, a2, all the way up to a sub n minus 1 and a sub n be some real numbers. But we need to make sure that our a sub n value is not 0. Now it's going to give us this big, long, general-looking polynomial. And it looks confusing because there's not any actual numbers in there. But basically what a polynomial is we've got x being raised to some power, and those x's can have coefficients in front of them. So what we end up with is a polynomial function of degree n. The highest power on an x that you see within your polynomial is the degree. And then the coefficient, the number in front of the x with the highest power on it, we call the leading coefficient. So we're going to look at some functions and we're going to try to identify if those represent polynomial functions. So what we're looking for is having x being raised to positive powers. And as we look at this one, we've got f of x equals 4x cubed minus 5x minus a half. Here we've got x being raised to a positive whole number power. And we're looking at those powers because the highest power within our polynomial is going to tell us our degree. So as we're looking at this x cubed, the highest power in here is a cubic power, so this function has a degree of 3. Now, as we're looking at our leading coefficient, so we look at that highest powered x, which is the x cubed. The leading coefficient is the number in front of that x. So I'm looking at this 4 here. So the leading coefficient of this polynomial is the 4. Now, as we're looking at our next function, we've got f of x equals 6x to the negative 4th plus 7. In order for something to be a polynomial function, as we're looking at those powers, they need to be positive whole numbers. So having a negative 4 power on here is going to make this one not be a polynomial function. And again, it's because that power in there needs to be a positive power, so we can't have negative powers when we're dealing with polynomials. As we take a look at our next function, we've got h of x equals the square root of 9x to the 4th plus 16x squared. And I see some polynomial things happening, but it's all underneath that radical. And the problem with this one is that we're not able to simplify that radical out of there. So having that square root in here makes this one not a polynomial. As we're looking at this last function in here, we've got k of x equals 15x minus 2x to the 4th. I can see that there are only positive powers in here. I can see that there are no radicals or roots. So this one is a polynomial. So as we're looking at identifying the degree, we want to find the highest power. There's no power written on this first x, so it's an implied first power. This last one has a power of 4. 4 would be the highest power in here, so this has a degree of 4. And then as we're looking at the leading coefficient, again, we want to look at the highest powered x, but instead of the power, we want to look at the number in front of the x. So we've got ourselves a negative 2 here. That's going to be it for this video. Thanks for watching.